Hello everyone, welcome to my channel. This channel is for educational purposes and focuses on people who put together theories of everything, um, groups of people, individuals, but their theories are in danger of being lost to history because nobody cares. And so I'm at least trying to resurrect them to the point that maybe somebody will start caring. And because I think that these are important theories that can really benefit people. And because I think that they have benefited me. So that's kind of what I'm doing. This is video number 213 on the reciprocal system of theory. And this is a theory that was first put forward by Dewey B. Larson, and he worked on it uh, pretty hard for 60 years, put together a great oeuvre of books and articles and um, talks, and had a few followers that have stayed the course since he died back in 1990. And we'll go over some of their work as well coming up here soon. But right now, we're looking at Larson's 1979 work called Nothing But Motion. And that's basically the essence of Larson's theories, that we live in a universe of motion. The universe is not made out of matter nor energy, it's made out of motion. And motion in Larson's system is the relationship between space and time. We can see that as being plausible because the main kind of motion that we know of, speed, is actually a relationship between space and time. The car is moving 15 miles an hour. 15 miles of space in 1 hour of time, space over time. And we can see that space and time are reciprocals of each other. You can say the car is moving 15 miles an hour. You decide to double the speed, then you would say the car is moving 30 miles per hour. But you could also say that the car is moving 15 miles per half hour. Both would be correct, and that is because of the reciprocal nature of space and time. You can either multiply one or divide the other. 6 of one, half a dozen of the other. And it becomes a little bit more difficult, though, because space and time are both multidimensional. This is what Larson calls their coordinate aspect. Coordinate space, which is a concept that we're familiar with, 3 or more dimensions of space, XYZ coordinates primarily, or WXYZ coordinates, if you're talking about like the Fuller's system, even though I guess he doesn't really identify them that way. But then we also have coordinate time. So unbeknownst to legacy science, Larson posits 3 or more dimensions of time. And then we also have clock time, the progression of time. Time is always getting later and later and later. This is a concept that we're familiar with. But what we aren't familiar with is clock space. Space is always getting farther and farther and farther apart. This was actually detected by the Hubble telescope in observing that all of the distant galaxies are moving away from each other. This is the progression of space, or the flow of space, clock space. And then we also have the discrete unit postulate. Both space and time come in only discrete units. There is no continuity. All of them come in chunks, very small chunks, but nonetheless chunks. And one chunk of space in one chunk of time is the speed of light. So the speed of light is 1 in Larson's system, and then above 1 is faster than the speed of light. That's what you would call, what Larson calls the cosmic sector of the universe. And then below 1 is what Larson calls the material sector, less than the speed of light. And that is the half of the universe that we're familiar with, where we make our observations and measurements. But because of the reciprocal relationship between space and time, we can extrapolate what we know about the material sector to the cosmic sector by merely reversing the roles of space and time. The simple example that I can just give you is that in the material sector, in the slower than the speed of light sector, we have coordinate space, XYZ coordinates of space, and we have clock time. The clock is always getting later and later and later. But in the cosmic sector, we have coordinate time, 3 or more dimensions of time, and we have clock space. Space is always getting farther and farther and farther apart. We reverse the roles of space and time, and we were able to extrapolate what is going on in the in the cosmic universe from what's going on in the material universe, or the material sector is what Larson, the term that he uses. Okay, now we are looking at his book, Nothing But Motion. Now this book is primarily on atomic physics. Now just to preface, the atom in Larson's system is a combination of motions. So first you have photons. There is really 2 photons at the core of every atom. And a photon is a simple harmonic motion, a wave motion. But a wave motion is a combination of motions. In Larson's system, a wave motion is a combination of a translational motion, a linear, translational motion, and a vibrational motion perpendicular to the linear motion. And then when you combine them, you end up with a sine wave. Now, some of Larson's followers have disagreed with that and said that the simple harmonic motion, or the wave motion, is actually a combination of 2 counter-rotating systems. So it comes what Nehru calls a birotation. And so this also creates a simple harmonic motion. And so there is a dispute as to which results in the photon. I tend toward the latter, but we will get into that controversy at a later point in more depth. But so regardless, the main point is that for this purpose is that the simple harmonic motion of a photon, 2 of them are at the core of the atom, and then when you rotate those photons in 2 different dimensions, then you get an atom. So an atom is a combination of a number of different motions. Now, when you have a cosmic atom, again, you're supposed to reverse the roles of space and time. So what you really have is you have this photon, which is in time, and the rotation is in space for the atom. When you have the cosmic atom, you have the photon, which is in time, and the photon, which is in space, and the rotation of the photon is in time. I think that's right, although it could be vice versa. I'll have to check up on that next time I have a chance. So anyway, we're going to take over here in Larson's chapter number 17 that's called Some Speculations. So he kind of just went through a lot of the different things about atomic physics, and now he's just kind of pointing in the direction of future studies, future things to turn from speculations into actual something harder, something more firm. Okay, the massless neutron already has a material type structure that is a negative vibration and a positive rotation. So I think when he's saying vibration, he's referring to the photon, and when he's referring to the rotation, he's referring to the atomic rotation. Negative would be in time, positive would be in space. So a negative vibration and a positive rotation for the massless neutron, and no conversion process is required. Likewise, no decay or fragmentation process is possible because this particle has only one rotational displacement unit. Progress toward the hydrogen goal must therefore take place by means of addition processes. Addition of a massless neutron to a positron, a proton, a compound neutron, or a second massless neutron would produce a particle in which there is a single rotating system of displacement, 2 on the particle scale. As indicated in Chapter 11, it appears that such a particle, if it exists at all, is unstable, and in the absence of any means of transferring one of the units of displacement to a second rotating system, the unstable particle will decay back to particles of the original types. Such additions will therefore accomplish nothing. The additions that are actually possible constitute a regular series. The decay product, the massless neutron, m 1/2-1/2-0, can combine with an electron, m 0-0-1, to form a neutrino, m 1/2-1/2-1. Another massless neutron added to the neutrino produces a proton, m1-1-1. As has been indicated, addition of a massless neutron to the proton is not feasible, but a neutrino can be added, and this produces mass 1 hydrogen isotope, m 1/2-1/2-2. So far as the rotational displacement is concerned, we now have a clear and consistent picture. By addition of the supply of massless neutrons resulting from the decay of cosmic rays to electrons and neutrinos, particles that are plentiful in the material environment, hydrogen, the basic element of the material system, is produced. But there is still one important factor to be accounted for. There is no problem in the addition of the massless neutron to the electron, but in adding to the neutrino to produce the proton, a unit of mass must be provided. The question that must be answered before this hypothetical hydrogen building process can be considered a reality is, where does the required mass come from? It appears, on the basis of the recent extensions of the theory, that the answer to this question can be found in a hitherto unrecognized property of particles with two-dimensional rotations. As explained in Chapter 12, the mass is t to the third power over s to the third power, the reciprocal of three-dimensional speed, whereas energy is just t over s, the reciprocal of one-dimensional speed. Obviously, there is an intermediate quantity, the reciprocal of two-dimensional speed, t to the second power over s to the second power. This has been recognized as momentum, or impulse, but it has been regarded as a derivative of mass. Indeed, momentum is customarily defined as the product of mass and velocity. What has not been recognized is that the reciprocal of two-dimensional speed can exist in its own right, independent of mass, and that a two-dimensional massless particle can have what we may call internal momentum, t to the second power over s to the second power, just as a three-dimensional atom has mass, t to the third over s to the third. The internal energy of an atom, the energy equivalent of its mass, is equal to the product of its mass and the square of unit speed, or the speed of light. So this is Einstein's equation, mass times the speed of light to the second power equals energy. t to the third over s to the third times s to the second over t to the second equals t over s. Matter times the speed of light equals energy. This is the relation discovered by Einstein and expressed as E equals mc squared. In order to provide the unit mass required in the addition of a massless neutron to a neutrino to form a proton, a unit quantity of energy, T over S, must be provided. The kinetic energy of a particle with internal momentum, m, is the product of this momentum and the speed. mv equals t to the second power over s to the second power times s over t equals t over s. Inasmuch as the massless neutron has unit magnetic displacement and therefore unit momentum, and being massless, it moves with unit speed, the speed of light. Its kinetic energy is unity. Thus, the kinetic energy of the massless neutron is equal to the energy requirement for the production of a unit of mass. And by coming to rest in the stationary frame of reference, the massless neutron can provide the energy as well as the rotational displacement necessary to produce the proton by combination with a neutrino. Here, then, is what appears, on initial consideration at least, to be a complete and consistent theoretical explanation of the transition from decay product to material atom. There is, of course, no observational confirmation of the hypothetical processes, and such confirmation may be hard to get. The conclusions that have been reached will therefore have to rest entirely on their theoretical foundations for the time being. It is worth noting that, on the basis of these conclusions, the hydrogen produced from the decay products originates somewhat uniformly throughout the extension space of the material sector. Inasmuch as the neutrino population must be fairly uniformly distributed, this is in agreement with other deductions that were discussed in the first edition and will be given further consideration in Volume 2 of this work. The standing of the conclusions that have been outlined is considerably strengthened by the fact that the two lines of theoretical development meet at this point. As stated earlier, the inflow of cosmic matter into the material sector is counterbalanced by an ejection of matter from the material sector into the cosmic sector in the form of high-speed explosion products. These are the two crucial phases of the great cycle which constitutes the continuing activity of the universe. But the slow process of growth and development that the arriving matter undergoes before it is ready to participate in the events which will eject it back into the cosmic sector and complete the cycle is an equally important, even though less spectacular, aspect of the cycle. Consequently, one of the major tasks involved in developing a theoretical account of the physical universe from the basic postulates of the reciprocal system is to trace the evolutionary path of the new matter and of the aggregates into which that matter gathers. Our first concern, however, must be to identify the participants in physical activity and to define their principal properties, as these are items of information that will be required before the events in which these entities participate can be accurately evaluated. Now that we have arrived, at least tentatively, at the hydrogen stage, we will defer further consideration of the evolution of matter to Volume 2, and will return to our examination of the individual material units and their primary combinations. Okay, now that is the end of chapter 17, some speculations, and chapter 18 is called Simple Compounds. So this is where Larson in the last 5 or so chapters of this book, gets into a little bit of a discussion of organic chemistry. Now, I guess, we went over matter and the formation of matter, subatomic particles, and then we went to cosmic matter, which he calls, cosmic rays when they come over into the material sector. And so we covered the atoms, and now he's moving into compounds, so molecules. How do atoms combine with each other to make even more complicated matter, simple compounds. Now, I think we'll start this. I maybe will read one paragraph today. I'm not sure that I'm going to cover all 5 of these chapters on organic chemistry right now. I think that there might be other things to look at instead before we get to this. But I think maybe we'll at least try to go through the first chapter and see how it goes. Simple compounds. In the preceding chapters, we have determined the specific combinations of simple rotations that are stable in the material sector of the universe. We have identified each of these combinations within the experimental range with an observed subatomic particle of atom of an element. We have then shown that an exact duplicate of this system of material rotational combinations with space and time interchanged exists in the cosmic sector, and we have identified all of the observed particles that do not belong to the material system as atoms or particles of the cosmic system. To the extent that observational or experimental data are available, therefore, we have established agreement between the theoretical and observed structures. So far as these data extend, there are no loose ends. All of the observed entities have been identified theoretically, and while not all of the theoretical entities have been observed, there are adequate theoretical explanations for this. Okay, we're going to end it right there, and probably even go over the same paragraph tomorrow when we start up on this chapter on simple compounds. This actually might be a good review. It looked like that first paragraph was a pretty good review. And, I remember reading these chapters in the past and not getting much out of them. So I'm going to kind of go along with this for the first chapter and see if anything clicks with me. And if it clicks with me, then I might be able to help make it click with you. So we'll see how it goes. But otherwise, thanks for tuning in, and we will see you tomorrow. Have a great day.